Howdy. There we go. Yeah, I'm here to talk about Rust, systems programming for web developers. I'm going to talk about how web developers can become systems programmers, not how to apply systems programming to web development. And for anyone not aware, Rust is a new language by Mozilla that's kind of in that C++ space. And when you start talking about how you're going to grow the Rust community, very quickly you people start talking about, well, do you think Rust is going to kind of beat C++, like it's going to just take all those people and move them over from C++ to Rust? And I think this is kind of short-sighted, like a misguided way of thinking about how you're going to grow a new language. So I argue instead, let's look for a different way to actually grow the Rust community. And if you look at web developers, that's one of the fastest growing and largest groups of developers in our community right now. And I think Rust will make systems programming more accessible to all those web developers. So rather than talking about, how do we just take this zero-sum pie and kind of shift it around, let's talk about how Rust can actually make that pie bigger and grow the overall systems programming community. And I think there's some historical precedents for this idea. If people remember when Rails 1.0 came out, there were many discussions about whether Rails would sort of take over PHP as the most common web language. And as we now know, that didn't happen. PHP is by far still the most popular programming language in the web due to things like WordPress. And Rails has allowed Ruby to sort of eke out a pretty sizable chunk of the web developer space. But what also happened, and people didn't sort of bank on this at the time, was that EC2 was coming in and becoming something that was very popular, something that people would actually use, and traditional ops was changing. And as we all know, Ruby has a really nice DSL, and so all these people that were writing Rails stuff started also writing tools. And out of that, we got this whole list of great tools that you see up on the screen here. And whether or not you use these tools directly, you actually use Ruby or Rails, I would argue that whatever language you use has been influenced by these tools and the way you operationalize that code in production today. And more recently, we're in this peak node sort of time where you can take kind of any UI developer, slap some Node on them, you got a full stack engineer, right? And what's interesting about Node, when you look at it, Node doesn't actually introduce like new technology concepts. Async I/O libraries have existed for decades, and also Rhino, which is a JavaScript interpreter, has existed for a long time as well. And so when Node came out, you have all these server-side developers, myself included, going like, I don't get it. Like, that's not going to replace Ruby or Python or PHP. Like, why are people so excited about this thing? And we sort of missed this whole movement, whereas web's continuing to eat the desktop, and these client-side developers are under all this pressure to build these really rich, interactive user experiences. And they're trying to talk to these server-side developers and say, like, we need it to work this way. I need, like, WebSockets. And, we got people, like, in the Rails community that are just not kind of seeing that. And Python's not kind of working that way. And PHP's way behind. But what you get is now you have these client developers who can take JavaScript, they're already familiar with it, and actually go down to the server side, use existing APIs or databases, and actually kind of take that and reshuffle them or combine them or split them into APIs and send those up over WebSockets, or make just kind of the whole thing much more dynamic and sort of allow them to do their job better. And again, we missed it. A lot of the server-side developers are putting up posts like Node.js is a cancer and putting up benchmarks like Fibonacci doesn't run well on Node, and we just sort of totally missed it. And I think something similar can kind of be going on with systems programming right now. I think systems programming is becoming a little more in vogue as of late. And we're starting to see people getting involved from outside traditional systems programming communities. And so we can kind of look at, like, well, why is this? And I would argue that the modern web stack is getting a lot more complex. Sort of gone are the days where you can kind of take Apache, mod PHP, spin up a MySQL database, and have a web server that sort of runs and sort of satisfies the business, right? Now we have services and even microservices, and we're splitting up even front-end and server-side concerns. So what happens is we introduce all these different components into our production environment. A lot of these components are written in C or C++, some Java, some Go. And I'm not even talking about the development tools that you're using like Git or terminals that are written in C and C++. This is just stuff that web developers have to use in production to orchestrate and sort of make everything work. There's kind of a big problem here, though, right? Because we have this big knowledge gap between all the people using these that are writing scripting languages and all the people that are supporting these, the few people that are supporting these that write C or C++. And what happens is those people, those open source maintainers, are only able to keep up with the sort of most high priority tasks. Like they're not paid, they're sort of volunteering. And that means they don't have time for ancillary things like documentation. I'd also argue that they don't have time to actually think ahead, too. They're being so tactical. And we can see this on Twitter. People are burning out, but they're just being so tactical and kind of maintaining these things that they're not able to think, well, what's the future look like, or how can I improve this by orders of magnitude? So the state of the art's being hindered. But I also think for web developers, this is a disadvantage to us because if we rely on people that aren't in web development writing these tools for us, we're missing core use cases. We've seen this. The browsers used to have standards written by TC39 that missed all sorts of use cases. And that's because TC39 was made up of people who were not writing for the web. That's changed recently, and we're getting better standards that come out of it. And we see this in the server-side development, too. I write PHP. There's a class called PDO for PHP Data Object. And when you instantiate this class for database access, it immediately connects to the database. Any web developer knows that the biggest bottleneck to your application is database. And so that's a core use case miss where the person who wrote PDO was a great C developer. His name is Wes. But he was not a web developer. So he missed this core use case, and that was like a decade ago. We still work around this today in PHP code. And we ask why aren't people getting more involved? Why aren't web developers sort of, moving in droves to go solve these problems? And there's a lot of sort of barriers to entry here, right? First and foremost, web developers, they prefer garbage collected languages. But if we're trying to write systems code where it really matters, we can't sort of afford the tax of garbage collection. So as a web developer, you have to actually start dealing with memory management, the allocating and the freeing of memory. In C or C++, that has a lot of foot guns. Put yourself in the shoes of a web developer who's trying to solve some pain point to scratch some itch. Probably they're at the workplace where they're having this problem because they're at, web scale. And they're like, hey, I'm going to write some C or C++ to go solve this problem. And they write some code. It compiles. No warnings, even if they have WAL turned on, no warnings. They ship it to production and just blows up spectacularly in their face, right? Either it's seg faults or they weren't careful enough and they introduced some big security vulnerability. That's just a tough order of business for someone to do. And I think thread safety is in much the same boat. Even the most experienced C++ developers continue to make mistakes when it comes to threads. In fact, the whole reason Mozilla started to actually look at funding Rust was because they would go into these competitions like Pwn to Own, where all these browsers would be sort of battle tested for security issues. And threads consistently were the main thing that security researchers attacked to exploit the Firefox browser. I think third, when you look at C or C++, it's not a very expressive language, right? So web developers, especially if you prefer a Ruby or a Python, you put a lot of stock in the fact that these languages are not only nice to write, but nice to read. Sandy Metz has even been quoted as saying, I will give up some CPU cycles to make my code more readable and more maintainable. And if you sort of hop into some popular C or C++ repositories out there, it's quite difficult to read. You have a lot of pointer indirection. You have a lot of macros being defined. You have a lot of code where the intent is not clear because they have modified the code in the name of performance. And so if you're trying to get involved in that language, or into that program, that's just it's a tough thing to do. So coincidentally, I think Rust solves these three things pretty well. Rust allows for memory management and memory safety without garbage collection through this sort of concept called ownership. And also, same thing for threads. You can get concurrency without data races. So it doesn't solve all the problems with threads, but a lot of sort of the, I'll call them 101 problems with threads are solved at compile time. And then lastly, there's this notion that you can have abstraction without overhead. so you can sort of have your cake and eat it too when you can write your code in a way that sort of feels good as a web developer, but doesn't sort of have all the performance costs that would come with that abstraction. So it's this concept of ownership that sort of solves these first two things in Rust. And ownership is a set of guidelines or principles that actually exist as conventions in C++, but that are actually codified in the compiler, in the Rust compiler. The piece of the compiler is called the borrow checker. And that means the compiler at compile time is the one who's trying to basically mentor you and support you. And so when your code compiles, whether in debug mode or production mode, you can be pretty well assured that your code does not contain seg faults, that your code does not contain use after free errors, and that your code has basically removed an entire class of memory leaks. Not all memory leaks, that's a halting problem, that's pretty much impossible, but a lot of the ones that a compiler can do are automatically removed. And what we sort of see as people that are web developers or just super non-experienced C++ developers, they start writing Rust code, is that the compiler gets in their way, right? They're trying to basically, do something new to solve a problem, and they write it in a way that they'd write some sort of scripting language to solve the problem, and the compiler just starts yelling at them. And because it's a computer, doesn't care how you feel, doesn't care how frustrated you get, it forces you to actually start changing your code and writing it in a way that's safe. And it won't let you get around that. What starts to happen, though, is what we've noticed, is that people start to sort of learn ahead of time that the compiler is going to tell me this is wrong. I'm just going to write it this other way instead. So that even if they stop writing Rust and actually go back and write C or C++, they can now actually intuit these ownership guidelines and principles that are conventions in C or C++ and actually go off and be even successful systems programmers in those languages. So the compiler starts acting like this teacher. In addition, we also get this second order effect where if you are someone who's new to a community, you're a web developer who wants to get involved in systems programming, most of us do that through open source. And in many languages, not even just C or C++, but even our scripting languages, you can write a patch that appears to work for you that actually blows up spectacularly when people start really using it, right? And then you get this hesitation because you're like, well, I don't know if I want to open up that GitHub PR because I'm going to kind of put myself out there. I might look bad. But what happens with the Rust compiler, it actually removes all of these sort of common errors and use cases from the code. And even if you don't have tests, many times you don't have tests when you're writing large portions of Rust, you have all this confidence that the code pretty much does what it says it does. Now, you may miss domain logic issues. You may have like bugs in your domain logic or business logic, but you're pretty reasonably well assured that you can contribute that code and it won't like seg fault in production and cause someone a lot of pain. So let's move on to this notion of expressiveness. Before Rust went 1.0, a couple people from the Ruby community got involved, Yehuda Katz and Steve Klabnik, among others, and they sort of looking at this Rust syntax, which was full of sigils, so like ampersands and @ signs. It looked more like Perl at the time. And they were arguing, hey, let's change the way that this syntax looks. And now the way that the syntax looks and feels is like a first-class consideration in the Rust code. And what came out of that is this notion of zero-cost abstractions, or what I like to call mullet-driven development. You can have code that looks like Ruby when you're writing it in your editor, but when it compiles down into assembler, it actually is running like you wrote high-performance C. Now, this is my only code sample in this talk, but I thought this was just a really succinct way to kind of demonstrate this idea of zero-cost abstractions. So here we have a list of numbers 1 through 10, and we are mapping over those numbers and multiplying by 2, then filtering over those numbers and dropping any ones that are greater than 5, and then finally folding over those numbers to accumulate those values into a single result. Now, if we were to write this in Ruby or Python, this would be 3 passes over that list, right? And if we were to then take this code and try to actually say, well, we need to make it more performant, we need to create this in like C, you would have to manually transform this from 3 passes to a single pass. Not only can you introduce bugs, but you actually then sort of lose the intent of the code you're writing and just make it harder to read and maintain. Now with Rust, you actually, this is working Rust code. You write it like this, and then Rust uses LLVM just to compile it down and make it fast. So if you're a web developer trying to get involved in a systems programming language, you can write it in kind of this functional way that is very popular now in the web communities and not worry about paying all the performance costs. Basically works the right way out of the box. So a lot of people actually think about Rust, they hear, hey, that compiler is really tough to work with, and it's sort of hard to get involved. Now, I think that's true, but I don't think Rust has sort of gone to the extremes that a lot of people think it has. I think Rust is a very pragmatic language. It goes to solve real-world problems, which should be of importance to web developers. And I call like this notion like optional correctness. So if you are writing your code in Rust and you're prototyping something out, you may not want to handle all the error conditions. Now Rust has these return types called options and results. And what you can do is you can just unwrap these things. And if you're in the happy path, if things are working correctly, you get your value back, you move on. But if there is an error, the code blows up right there like in pre-production, like when you're writing the code. And that's fine, you're prototyping, right? Like you're not actually trying to ship this yet. And when you actually finally solve the problem, you're done spelunking or exploring through this problem space, you can go back and actually remove those unwraps and actually handle the errors properly. This is nice. So, we've tried to solve these same problems in other languages like Haskell, but they force you to sort of handle all the conditions up front before you really get something working. I think we can extend this idea of optional correctness even to the result and option types themselves. If you recognize these terms, these are similar names or the exact names to monads. But in Rust, they're not actually true monads. They are more pragmatic. You can actually exit the function or even the entire program when you start destructing these types, which is really nice if you're handling errors. So again, Rust has like this very pragmatic approach to solving problems. They're not worrying about like theoretical correctness. And then the most common way you can sort of you can opt out of correctness in Rust is to wrap your code in an unsafe block. So as nice as the Rust compiler is, there are times when you have to actually do unsafe things. Either the problem requires it, or you're actually interacting with all of the other languages out there, whether it's C++ or whether it's a scripting language. You have to have some layer of unsafety. And Rust allows you to sort of demarcate this. And so most, 99% of your code can be safe, and you can opt out for that 1% of code that you now need to really focus on. And actually, it hints to everyone else, this is what you need to focus on because it wraps it explicitly in those unsafe blocks. And this is why I think Rust has such a nice foreign function interface story. So if you're a web developer and you're trying to get involved in systems programming, you probably don't want to take your entire program and rewrite the entire thing in a new language. Not only is that take a lot of time, there's a lot of risk there, it's probably not worth it. A lot of the code probably actually works fine, and you're honing in on a few problem spots. So what you actually can do with Rust, since the FFI is so good, you can profile your code, find the hot spots, and then rewrite those in Rust. I've done that myself. I took Gary Bernhardt's Selecta program, which is like a fuzzy matcher over text for searching through like text on your editor and stuff. And I looked at it, and the search algorithm was the hottest part of the code. And because it was Ruby, it wasn't as fast as it needed to be. I rewrote that in Rust, and it was actually pretty easy just to compile that Rust into a library and interface it into the Ruby code. And there's actually lots of examples out there where people are doing this now. You can do it in Ruby, Python, and PHP pretty easily. Those are all written in C. And now you can even do it in Node, which is C++, but there are now facilities to do that. And even entire layers of libraries that make that really easy for you to get involved in and not have to worry about some of the nitty-gritty details. And the flip side's true, too. So C is everywhere, right? Pretty much everything, when you boil it down to, is on C. So if you are a developer and you want to get involved in a existing project that's written in C or C++, you don't actually have to write C or C++. You can actually write Rust and interface that into C or C++ directly. So you can start augmenting bits of common libraries out there. Like, we're not going to rewrite the Linux kernel in Rust. We've seen that sort of on that orange website out there. People sort of sometimes say, we're going to rewrite this entire Linux kernel in Rust. It's not going to happen. What we can do is we can introduce, bits of Rust into the ecosystem. And that's actually what Mozilla is doing with the Firefox browser. That's all written in C++, but now URL handling in Firefox Preview is handled by Rust code. And so I kind of want to leave us with this idea that systems programming is hard because systems are hard. It's hard to write drivers for the Linux kernel. It's hard to make a program like Nginx run really fast. But we should use a language that actually solves all the problems that can be solved with a compiler, and then use the human brain to actually focus on things like optimization or reasoning about really hard problem spaces. So if you're interested in Rust, there are a number of links on these slides you can jump into, whether you're a web developer or otherwise. Some of these are official links. Some of these are community-driven links. I think they're all good. And also, if you're an LA local, I run the LA Rust Meetup. So I encourage you, whether you're brand new to software development or whether you're experienced, if you're interested in learning Rust, we meet in the middle of the month on Wednesdays in Culver City, pretty close nearby. And we're a very welcoming group, so you can get involved. We sort of specialize in sort of ramping people up, and we know you're probably not writing Rust at work, so we let you do that at these meetups. So come on and join us. Again, my name's Herman. I work at nordstromrack.com/Hotlook. Thanks to my team for coming out and watching me. Of course, we are hiring. Get at us. There's my information. If you want to learn more too, please hit me up. I'm happy to talk about this stuff. I have lots of good blog posts about getting introduced to Rust, especially if you're trying to reason about various things and you don't understand some of the different ownership types in Rust. Check those out. I don't have time for questions, but please get at me at the lunch area, and I'm happy to talk through things with you and answer anything there. Thank you.